continuing on with our look at how percents can be used in various ways. There's another problem on page 10. So we're told that it's common for stores to advertise a percentage off. Definitely, I see that all the time. And then you'll be told the discount is reflected in the market price, and then you just have to trust that whoever did that calculation is correct. They're not always correct, by the way. Sometimes whip out your calculator and check it out. So suppose that a refrigerator is listed as 30% off with a sale price of $749. What's the original selling price? So I'm going to do the same kind of setup I did before. We're going to say 100% is the original price. And then we're told that we're getting a 30% discount. So this is our discount, which means that when we do this discount, what remains after the discount is 70% of the original price. So this would be the new price is 70% of the original price. Well, if we, so with that knowledge, we can then say, all right, 0.7, the decimal version of 70%, times the original price, whatever that was, which we don't currently know, should equal this new sale price, $749. Which maybe we should call this, instead of new price, the sale price. All right, so if we want to calculate that original price, we're just going to divide both sides by 0.7. And we'll get the original price. I'm going to call it OP. And I'll flip over to Desmos to do this. So 749 divided by 0.7 gives us 1070. Now, I want to show you something real quick. Remember, we said that we got a 30% discount. So let's quick calculate what's 30% of 1070. So 0.3 times 1070 gives us that discount. So the amount of the discount is $321. Let's double check our math here. So what's 1070 minus 321, right? So we had our original price. We get a 30% discount, so a savings of $321. When we do that subtraction, we do get the 749, which is exactly what we were claiming here. That's a quick way to check your math. All right, let's do one more here. So we've got these two coffee shops, one named Shakey's Caffeine Shack. Clever, right? They have a low price of just $3.15 or $3.50, but they're going to offer it for $3. Why not just give it away? That's crazy. And then, is this a better offer than 20% off the coffee shop across the street is offering? Well, there's a problem with this problem, and that is we don't actually know the price of the coffee shop from across the street. So we're going to have to go ahead and make an assumption that they both sell it for $3.50. Okay? So we're going to say, let's say Shakey's Caffeine Shack, the original cost was $3.50, and then the sale price is $3. And then we're going to say that across the street shack, their original price is $350, and they're offering a sale of 20% off. So two ways we can do this. To me, the fastest way, or the thing that just jumps out, is let's calculate how much are we saving over here. So $3.50 minus $3, I think everyone's would be good that we've got 50 cents savings from Shakey's Caffeine Shack. To calculate the amount of savings so that we can compare the two numbers to see which one is saving the most, we're just going to calculate what's 20% of $3.50. Well, 10% of $3.50 is 35 cents. So 10% is 70 cents. Let's double check that using Desmos. 0.2 times 350. Yay, I was right, 70 cents. So which one is the better savings? Well, looking at this, comparing the directly 50 cents to 70 cents, the across the street shop is cheapest, assuming that they serve exactly the same quality of coffee. Now, there's another way we could do this. We could say, what percent savings did we have here? So then we could compare the percent off between the two. What we would do is take the savings and calculate this part is what percent of that whole. So we'd be doing 0.5 divided by 350. So jumping into Desmos here, 0.5 divided by 3.5, that gets us the percent discount that Shakey's Caffeine Shack was given is approximately 0.143. Notice I'm rounding this 2 to a 3, meaning we got a roughly 14.3% discount when they dropped it from $3.50 to $3. So there we can now directly compare the percents and note that the same answer we had over here, that the across the street shop is cheapest or has the better deal with their 20% off compared to the 14% off. So that leads us to two formulas that I was more or less demonstrating here. That's the idea of percent increase and percent decrease. So if we get a quantity that's getting larger, then we can calculate the increase by the amount of increase divided by the original amount, or this idea of new minus original divided by original. If it's getting smaller, we do essentially the same thing, the new amount minus the original. So they're same formulas. The difference is this percent decrease is going to be a negative number. Notice how I did that in this calculation. This is the amount of decrease. Now, I wrote this as a positive value. So really, if I was doing the formula correctly, I should do a subtraction. Now, we're going to do some examples of this. I think that was confusing what I just said. So we'll do some examples. But I think maybe a better way to write these two formulas, is to call it percent change and just make it real simple. Do the new value minus the old value divided by the old value. Note, what's important is that the number you're subtracting is also the number you're dividing by. And then from here, if we get a positive number, so if the new value was larger than the old value, when we do the subtraction, we'll get a positive number. That is going to represent percent increase. If we do the subtraction and we get a negative number, again, we can predict this. If we see that the new value is smaller than the old value, we will get a negative number. That's going to look like percent decrease. So let's do one. Here we are on July 20, 2009, the federal minimum wage was raised. Now, here, those of you that are readers, that enjoy English and things, math follows along right with that. All the clues there are relevant. So we know this is going to be a percent increase because the new value is going to be larger than the old value. Note we also said find the percent increase. So let's identify this. The old value before July 24th, 2009 was $6.55. The new value after this law went into effect, notice it's only federal minimum wage, is $7.25. So just using our formula, we're going to note that we do $7.25 minus $6.55 divided by $6.55. This will give us our percent increase. Now I'm going to use Desmos to walk us through this. You're welcome to use calculators. I encourage you to use Desmos. I'll show you in a later video or separate kind of from all of these how to download Desmos to your phone, and you can use it on your phone while you're working through class, or just right there on your computer. So we need to be careful how we do this. So let me show you this in Desmos. I'm first just going to get the value of that numerator. In other words, 725 minus 625. How much money was increased there? Now, oops, did I say 625? I meant 655. So the actual increase in pay was 70 cents per hour. What a huge increase, right? And then we're going to divide that by 655. Now notice when I hit the division key, it only divides the 655 by the number I type. So I'm going to hit the backspace. I'm going to type in parentheses and then division because we want to divide that subtraction, not the number we're subtracting. by 655. Notice this value, what I'm writing down is the approximate. We'll do 1 decimal place after we convert it to a percent. So 3 decimal places here. I'm going to round to this value, 0.106. Note the number after the 6 is an 8, so our answer is 0.107. All right, what is that as a percentage? Well, this is the decimal version of the percent. So if we want to convert this into an actual percent change, we have to multiply by 100, which tells us that was a 10.7% increase in pay. So let's go back to our formula that we used up here and let's modify it slightly. If we want the number that is spit out from the formula to actually be a percentage, we need to include that multiplication by 100, just so you don't forget. So what I'm going to do is put a big set of parentheses and just times 100 at the end, and that guarantees that the decimal result, so this will come as a decimal, that when we multiply it by 100, we will get the percent we're looking for.